Thank you all for coming. We are really excited to have you guys and join this event together. But before talking about all the data science stuff and introduce all the amazing community and company to make this event happen, I want to share some story with you, my personal story. So a few years ago, I almost had become a seller selling mobile phone in a Japanese supermarket. At that time, I was still in school, but I didn't study statistics or math or anything related to data science at all. But I was really into data and think that that is so cool to use data to do some product optimization and drive all the changes. And start thinking about, yeah, I want to be a data analyst. That is so cool. So I started meeting people and having all the coffee and having all the online courses learning SQL and all the coding stuff. But I didn't realize that becoming a data analyst is really, really hard. So the first challenge is every time when I go to the meetup event, I'm talking about data science stuff with other people, there's so many terms I don't understand. And even though I'm smiling like this, I was like, what the hell is ETL? And I got so nervous because there's so many things I don't understand. And the second challenge is that there's so few companies get back to me for interview. And there's a very few company like the position for selling mobile phone in Japanese market because I speak Japanese. And these are the very few opportunity I can get at the time. So I was so desperate. I was starting thinking about maybe data science is not a route for me. Maybe I can become a data analyst. But there's one thing really supported me, and it really inspired me and make me become a data analyst today. It's the community. All the women are so supportive, and when I look around, I wasn't alone. There's so many women are doing the same thing. Even though they know data science is so hard, it's always surrounded by all the guys. It's really hard to get into. It's really feel so frustrated, but they're still taking so many classes, going to the meetup, like you guys are here now today. So I really appreciate the community, and you should really proud of yourself because become a data analyst or a data scientist is not easy at all. And a resource like a Women in Data Science conference or all the women community is so important to support us in this career path. So now I'm going to introduce the really important community and company to make this event possible today. So just come up on.
Hi, everyone. So my name is Milan. I'm a data scientist at Airbnb. So we are very glad to host you today. Welcome to the event. And just to let you know, Airbnb also hosts other tech events, tech talks on a regular basis. So we are definitely excited to have you coming to the office once in a while and talk to the community and enjoy everything going on here. Thanks again for coming, and I will pass it to you.
Hi, my name's Erin Liddell. So if all of you don't know, this is actually a joint event put on by 3 different meetup groups, and I guess sort of also with Women in Data Science Conference, so technically four groups coming together, and the group that I run is called Women in Machine Learning and Data Science, WIMLDS for short, even though that's a very long acronym. And we've been around for 3 or 4 years now, and we have meetups in a couple different cities, I guess 8 different cities, including Nairobi, Africa, which is one of our newer groups. And we we got the idea of starting the group in 2013 from the Women in Machine Learning Conference, which has been around for 8 years before that. And so now there's all sorts of women in machine learning meetups, and so now we can all enjoy them together. So anyway, that's, and if you want to join the group, wimlds.org is our website.
Good evening, everyone. Thank you for coming. My name is Britt, and together with Chloe, I co-founded a group called She Talks Data. She Talks Data holds monthly intimate gatherings throughout the Bay Area that's focused on enriching, empowering, and connecting women who work in the data industry. So we've had speakers that have represented a variety of companies in the Bay Area, from engineering to statisticians and some data scientists as well. We host our meetings in San Francisco as well as the South Bay. So if you'd like to learn more about our group, we would love to have you join us one day. You can visit us at shetalksdata.com, and Chloe and I, of course, would be happy to talk to you after the event too if you're interested. So for tonight's agenda, we're going to be streaming 2 talks, and then we'll follow that with some live lightning talks. The first talk we're streaming is going to be renowned data scientist, Dr. Fei-Fei Li. She will discuss the key ideas and cutting-edge advances in the quest for visual intelligence in computers. We will then be streaming a talk by Megan Price, who is the executive director of the Human Rights Data Analysis Group, who will share her group's experiences using machine learning to determine how many people have been killed in Syria. But first, Dr. Fei-Fei Li, she's currently Chief Data Scientist of AI and ML at Google Cloud, an Associate Professor of Computer Science at Stanford, and Director of the Stanford Artificial Intelligence Lab. She was founding director of the recently established Stanford Toyota Center for Human-Centric AI. Dr. Li's main research areas are in machine learning, deep learning, computer vision, and cognitive and computational science. Dr. Li obtained her BA degree in physics from Princeton with high honors and her PhD degree in electrical engineering from California Institute of Technology. Enjoy the first streaming.
I think this is the second time I joined you, and it's just very inspiring to see all the women in data sciences from academia and industry and NGOs. So great honor to be here. As you know, I'm a professor at Stanford. My research focus in artificial intelligence, computer vision, and machine learning. I'm also on sabbatical this year at Google Cloud. You heard from Diane Green earlier this morning, working on democratizing AI for everyone and every business. So today I'll share with you a little bit more about what I do, artificial intelligence, especially from a research angle. I don't think I need to convince you that we have entered the age of AI. Everywhere we look, the applications and technologies of AI is already or going to impact every aspect of our life. So a little bit of a historical view about AI. You all know this man, Alan Turing. He was a cryptologist, mathematician, and working with the Allies during World War II. And it was Turing, among others, that inspired humanity with a very important question of how do we build intelligent machines. So Turing says that to build intelligent machines, it may be best to provide the machines with the best sense organs that money can buy, and then teach it to understand and speak English. So while back 60 years ago, Turing's hypothesis was mostly a wild imagination of a scientist and a mathematician, but he already talked about 2 really important ingredients that will guide modern artificial intelligence research and technology. One ingredient is sensing. Sensing is a very critical part of enabling any intelligent machines, especially collecting information from the world. In my world, visual sensing is a huge part of it. Of course, there is speech, there's haptics, and there's other parts of sensing. But vision does occupy a very special place in all of our brain. In fact, more than half of our brain, human brains, are involved in visual processing. It's the biggest sensory systems in the cortex. Another part of Turing's hypothesis is language. Language is really unique to humans, this complexity. And Turing hypothesized that in order to build that kind of intelligent machine, we have to solve the language problem. But Turing really, it was a wild imagination. He had a lot of ideas, but whatever he said was really only the first step. From that point on, it's been generations of researchers in AI that has been working on the problem of AI. And there's one local hero of mine that many of you probably don't know, and that's a Stanford professor called Terry Winograd. Some of you might know him. Terry is one of the first generations of AI researchers. He did his PhD at MIT with Marvin Minsky and many others. He then moved to Stanford, in fact, that after his AI research, he also was part of the pioneering scholars that brought up the field of HCI, human-computer interaction. But Terry is a very important figure in the history of AI. Before I say what his contribution is, I'm also very lucky he's my neighbor. So this is literally in front of our houses. So I feel like the value of my house, has increased because of Terry. So Terry operationalized Turing's idea of building this intelligent machine. He's not the only person, but he really, among many, was in that generation that started to put forward the three ingredients of building the AI machine, the intelligent machine: the syntax part, the semantics part, and the inference part. And for him, it's really important that the syntax, syntax is about understanding the structure, whether it's language structure or 3D layout structure, structure of the world. Semantics is the meaning of the world, the language or the objects, and so on. And inference is the prediction. And in one of his most celebrated work is a system called Charloux that Terry put together a demo system that included these three ingredients, mostly focusing on language. And this is the early work. It's probably one of the very first AI system that completes that idea of an intelligent machine, and it's called Charloux. And Charloux assumes there's one big assumption. Charloux assumes vision is solved. We live in a simple block world, and it's where the language inference happens, where a machine will listen to a human instruction like pick up a red block, a big red block. The machine would look at the world, do its inference, understand there is a big red block, and lift it up. And then the human can give another instruction, find a block which is taller than the one you're holding, and move it to the gray box. And then the machine, Charloux, would go through its inference again, parse the sentence, and understand the structure, understand the syntax and semantics, and decide that the blue block is the bigger block, and put it in the gray box. And it just goes on. I'm going to skip the next examples. So Charloux was really quite exciting in the 70s, along with a few other work in this block world that really showed us, wow, we can start to build machines that Turing was imagining. It's the machines that can understand human language and perform tasks. But to be honest, while it was pioneering that whole set of work, it didn't push AI beyond the laboratory demos. From 70s to 90s, we haven't seen the kind of progress that we wanted in artificial intelligence. And one of the biggest problems was actually hidden in the algorithms of the early systems of AI. And it was the rule-based, hand-designed rule for inference and very little learning. So this is not meant for you to understand, but these are examples of the rules hidden under systems like Charlo. And while it was okay for a block world that's heavily simplified, it has a lot of issues. It has a scalability issue. It's hard to anticipate all possibilities. For example, here's an example. If you talk to Siri, "Hi Siri, call me Fred," Siri would say, "Okay, I'll call you Fred from now on." But what if you say, "Siri, call me when you get a chance"? Well, the rule-based system would infer and think that when you get a chance is your name, and Siri would call you when you get a chance, and that's not what we mean. So scalability is an issue with hand-designed rules. Another issue is adaptability. When we design rules, we design it for a specific situation. For example, language parsing. We can design rules for English parsing, but how about Japanese or Chinese or any other language? And of course, hand-designed rules are very difficult to adapt for open world, especially when there are situations that are hardly unseen or unique. So these are the problems that kind of slow down the progress of AI going into real world applications. Well, machine learning came to the rescue. Starting the late 80s and 90s, machine learning became a blossoming field that really injected new life into AI. So for those of you who are not familiar with machine learning, here is a very simple summary of the difference between traditional rule-based programming and machine learning. The key here is that in the traditional programming, the program is designed by humans, whereas here we have data and then a learning algorithm that learns the right program to execute or predict or infer the output. So that is the key difference here. And you hear a lot of buzzwords these days about machine learning. One of the biggest advances these days in machine learning is deep learning and neural network. And here's one view of it. Deep learning and neural network is a subset of the machine learning algorithms in the bigger machine learning families of algorithms. Right now, the biggest advances comes into supervised learning with neural networks such as RNNs and CNNs. So where did the brief history of deep learning can date back to neuroscience research, actually. Well, first, there was in the 50s, there was ideas from Rosenblatt about perceptions of connecting neurons, looking at neuroscience data. And important work came in from Hubel and Wiesel as neuroscientists who tested out the cat neurons in the primary visual cortex and learned the hierarchical structure of neuronal architecture. That laid the groundwork for modeling the hierarchical neuronal architecture in the 80s, starting from Neocognitron by Kunihiro Fukushima. And then one of the most important work was convolutional neural network by Yann LeCun in the 90s and 80s, where the learning rule was unified under backpropagation by people like Geoff Hinton. And then perhaps some of the students here know 2012 was the defining moment of the renaissance of deep learning by this paper by Geoff Hinton and his student Alex Krizhevsky called AlexNet, which is really, it was more or less similar to the 90s work in convolutional neural network, but this particular paper combined three really critical ingredients that really set off the avalanche of deep learning. The first ingredient is the neural network algorithm. The second ingredient is big data. Lots of work from many people, including my own lab. And then the third ingredient is hardware, the GPUs for parallel computing. So the convergence of these three important ingredients really was set off this really remarkable renaissance and revolution of today's deep learning and artificial intelligence. But that's only the tool part, the hammer part. We still have to solve some of the fundamental questions in AI. So now that we have this machine learning hammer, let's go back to Terry's the structure of the AI operation, which is solving the three problems: syntax, semantics, and inference. I'm just going to offer a few examples to show the progress, mostly a little bit Stanford-centric, but still give you a flavor of what's been happening. So a lot of work in the early 80s and 90s and early 21st century has focused on syntax understanding in the visual world, mostly 3D structure of the visual world. So this is a Stanford work, very famous one by Professor Mark Lavoie, Digital Michelangelo project, that shows how we can do 3D reconstruction. You might not have heard of this work, but you have heard of self-driving cars. So that 20 years of 3D vision, visual reconstruction research have laid the foundation for today's self-driving car technology. So that's a very important, important work. And then after the 3D vision era, computer vision and machine learning start to focus on semantics. That's a really important problem. Image classification, object detection, image understanding. That's when ImageNet from my lab played a role in this era of research, where we put forward challenges to ask worldwide researchers to participate in the research of ImageNet challenge. I only have 1 minute? Oh, wow. All right. Okay. So I'm just gonna go really fast, because ImageNet, this is where you now see Google Photos, Facebook tagging, and e-commerce uses this technology. Of course, there's starting to combine syntax and semantics, and this is a really fun work from Stanford. This is the technology that's going to get us AR, VR, and I'm not going to talk more about that. So I was going to talk about two work, but at this point I just flipped through. So currently my lab is focusing mostly on combining vision and language. We think this is really towards realizing Turing's dream and really Terry's dream. And on this front, we recently have two work. One is a data set that benchmark not the semantics like ImageNet, but the syntax and the inference of vision and language. This is a collaboration with Facebook of a synthesized block world and how we can benchmark the deep learning algorithm. I'm not gonna talk about this, so let me just fast forward. The last work I was going to talk about is story writing to bring out the semantics and some syntax of the pictures. Last year I talked about writing one caption, but this year we have taken this further and start to write multiple stories from a scene and eventually generating paragraphs of images, and that's the latest work I want to share with you. So at this point, I see Margot here. So I will stop at this point. Thank you.
Oh, thanks so much, Fei Fei. I do want to point out that Fei Fei maintains a really informative website as well, with beautiful publications, and so it would be easy to look up a little bit more. So we'll start with the Twitter question now. We have just 2 minutes for some questions, Fei Fei.
So we have 2 related questions. One is, how do you prevent teaching artificial intelligence our unconscious biases? And then how do you prevent, identify, and then cleanse the bias from the artificial intelligence?
That's a great question. I think there's an increasing awareness of bias introduced to data. I like to make an example. Just type the word grandma in your favorite image search engine. You'll see the bias already, or any word that comes to your mind. I think, how do we prevent? I think awareness is a huge part of it. For example, NIPS already has workshops to discuss data bias. There is a lot of research labs that are starting to pay attention to this. We need more awareness. We need more research to look at the bias of data and to combat the bias of data. That's an important first step.
Hi, thanks for a great talk. You talked about how machine learning algorithms have allowed us to transcend the limitations of rule-based systems, but with that increased flexibility also comes a lack of safety and an inability to provide the kind of guarantees on the behavior of the system that you would be able to provide under a rule-based system. Do you think that there's still a role for rule-based thinking in guaranteeing AI safety, or do you think that can also be provided within the framework of statistical learning, machine learning?
So I think that's a great question. I think there's a lot that's packed into it. So rule-based system is not necessarily safe. So safety, security attack comes under different possibilities. So I think so we need to dissociate the issues of rule-based systems is not really. Or the strength of rule-based system is really not about its safety and security. It's more about the inference. On the other hand, I agree with you that AI and security is really an increasingly interesting topic. For example, there is a lot of research on adversarial examples to AI systems. There is also work on how do you because looking at the inference behavior, infer back what the data or the features of the data is doing. And there is a recent work from Google Brain of how do we de-identify like healthcare or sensitive data. So all these are really important areas of research. But you also asked the question of, is there a role for rule-based system to play in today's statistical learning? My hunch is there is actually, because we still are very far from understanding what's knowledge representation, what's inference under structured knowledge, and this might also combine ideas from the earlier work.
Great. Well, thanks so much, Fei Fei, for coming and joining us. Wonderful.
All right, our next talk before we continue on to live lightning talks will be Megan Price. Megan designs strategies and methods for statistical analysis of human rights data for projects in a variety of locations, including Guatemala, Colombia, and Syria. Her work in Syria includes serving as the lead statistician and author of 3 reports commissioned by the Office of the United Nations High Commissioner of Human Rights. The Human Rights Data Analysis Group produces unbiased scientific results that bring clarity to human rights violence and ensures that the truth is the most accurate truth possible. The work the group does is especially important given the current political climate. So we hope you enjoy this last talk.
One Bit of housekeeping for those who are particularly observant out in the audience. I'm very pregnant. And I'm also just getting over a head cold, and that combination of things sometimes means when I speak publicly, I get a little out of breath. Nobody panic. It doesn't mean I'm going into labor. It's just a reminder that sometimes I have to slow down a little bit. So, with that out of the way, let's get started. This morning, I'm going to tell you a little bit about my organization, who we are and what we do. I'm going to tell you about the two primary analytical methods that we use to do our work. I'll give you just a couple of examples of code snippets to let you get a sense of what our day-to-day work is like, and then I'll wrap things up. So I'm the executive director of an organization called the Human Rights Data Analysis Group, or HRDAG. We're a nonprofit. We're based in San Francisco. And we're essentially the behind-the-scenes scientists for human rights advocacy organizations. And my co-founder, Dr. Patrick Ball, has been doing this work for 25 years. And over those 2.5 decades, our team collectively has been really fortunate to partner with a wide variety of human rights advocacy organizations. Some of those are big international groups you may have heard of, Human Rights Watch, Amnesty International. We've worked with a variety of branches of the United Nations. We occasionally work with truth commissions, and we sometimes work with local, grassroots, non-governmental organizations. Now, the shape of our work, the outcome of our work, really varies on the specific project and the specific setting. Sometimes we write memos, sometimes we're a footnote, sometimes we're a technical appendix. But I think one of the most visible ways that our analytical work comes into play is when we're asked to provide expert witness testimony in court cases. As Patrick Ball was in 2002 at the International Criminal Tribunal for the former Yugoslavia, when he was asked to testify against Slobodan Milosevic. And here he's presenting patterns of refugee flow across the border into Albania and patterns of known killings during that conflict. He also testified in Guatemala in 2013 against General Efrain Rios Montt, the former de facto leader of Guatemala in the 80s. And here he's presenting a comparison of the relative risk of death for members of the indigenous population as compared to members of the non-indigenous population. And this comparison allowed lawyers to make an argument that the patterns of violence were consistent with what you would expect to see with targeted killing aimed at a specific ethnicity. So patterns of violence that would be consistent with acts of genocide. Rios Montt was found guilty of acts of genocide. Unfortunately, that verdict only stood for 10 days. The Guatemalan Constitutional Court overturned that verdict on a legal technicality. And this case is continuing to wind its way through Guatemalan courts. Excuse me. Most recently in 2015, Patrick testified again, this time in Senegal, against the former leader of Chad, Hissène Habré. Here he's presenting the crude mortality rate that occurred in secret prisons run by Hissène Habré, run by the secret police, managed by Hissène Habré. And this trial has the most positive outcome of our stories so far. In 2015, Patrick testified. In 2016, the judges came back with a guilty verdict, sentenced Hissène Habré to life in jail. So far, that verdict has stood. So what are we actually doing when we're presenting these results in court? Well, for most of our projects, we rely on two specific analytical methods. And the first one is this big class of methods called record linkage, or in various other applications, database deduplication, entity resolution. Fortunately for us, this problem arises in a wide variety of fields and applications. And so this is an incomplete list of the references that we rely on in our evolving thinking about this problem. Given this conference, I mostly want to highlight the last bullet point that we rely very heavily on specific modules in Python to carry out much of this work. And that's the specific example I'm going to touch on in a minute. But I do want to mention the second analytical method we use, which we refer to as multiple systems estimation. Now, for the statisticians in the audience, you'll know that MSE usually means something totally different. But we prefer to call this multiple systems estimation. It was developed 150 years ago in ecology for studying the size of animal populations. And there it's called capture-recapture. But as a human rights researcher, I try to avoid talking about capturing humans. So I prefer to call this method MSE. It's a very broad class of methods. Again, this is an incomplete list of references that we rely on. And to highlight that last bullet point, right now we primarily implement this work in R using two specific packages that fortunately for us were written by friends and colleagues. The DGA package was written by Christian Lum, James Jandro, and Patrick Ball. And LCMCR was written by Daniel Manrique Vallier. And both of those implement MSE models using a Bayesian, a Bayesian approach. So I'm not going to have time to talk much about MSE today, but during the Q&A or offline afterwards, I'd be happy to get into that. To get into our specific example this morning, this project started in 2012 when the United Nations Office of the High Commissioner for Human Rights came to us and said, we have these 4 different sources that are recording information about people who've been killed in Syria. And that's a little unusual for us. Usually we have one trusted partner on the ground who provides us with information. We're not really sure how to make sense of this particular data landscape. And so they asked us to help them analyze and describe these 4 different data sets. So for a couple of years, we co-authored a variety of publications. This one is somewhat out of date, but this is the last official publication that we wrote with the UN. But it's important to note in this headline that it's missing 2 important modifiers. This number describes the number of documented, identifiable individuals who've been killed in the ongoing conflict in Syria. And if you think about violence and conflict violence, it should rapidly become obvious that that's a subset of all victims, because not every victim is identified. Not every victim's story is told right away. It may be days or weeks or months or years before we hear certain stories from the conflict. So inevitably, this is a subset of those total number of victims. And I'm going to come back to that at the end, so I just want you to sort of think about what that means for our data and our analysis. But for now, we'll start with what we do know, which is based currently on 4 sources: the Center for Statistics and Research Syria, the Damascus Center for Human Rights Studies, the Syrian Network for Human Rights, and the Violations Documentation Center. And each of these groups collect lists of named victims. And from the beginning of the conflict through the end of 2015, they've collected over 400,000 records of named victims. Now, I need to be very clear here. That in no way implies that that is the number of victims. There is a lot of duplication in that collection of records, because many victims are reported multiple times to the same source, perhaps from different community members, or they're reported multiple times to different sources. Perhaps their family member reports them to all of the sources that they have access to. So the first thing we have to do is deduplicate those records. And what do those records look like? This is a screen grab from the public-facing website of the Violations Documentation Center. This is part of their advocacy work. They think, and we agree, that it's important to raise awareness about these victims, to tell their stories, to say their names. And most of the lists look similar to this. They are the names of the victims, the date and location where they died, and any other demographic information they've been able to collect. And that's where we get to this record linkage problem, which HRDAG sort of organizes in this very full diagram. And I mostly just show this to say there are a lot of steps involved. I'm going to tell you about 2 of them today. But what we do is supervised record linkage. So all the symbols on the outside, everything that starts with a TS for training set, is data that goes out for human review. And everything down the middle is what we automate and code and rely on computers to help us do. If you want to get into some of the more technical details, we've been building out the tech corner on our website. Last year, Patrick wrote a geeky deep dive on some of our blocking techniques. Last summer, he also wrote about clustering and solving the right problem. I really enjoy this one because he describes, as I'm sure all of us have experienced, really enthusiastically solving the wrong problem multiple times. before you find the right one. But again, I'm just going to focus today very briefly on compare and classify, kind of in the middle of this diagram. So if we think about pairs of records, and we just want to ask ourselves, does this pair of records refer to the same person or not? And if I have any Arabic speakers in the audience or watching the live stream, I apologize. When I mix Arabic and English, one of them has to end up backwards. So all the Arabic on these slides is backwards. But there's two ways we can think about this comparison. We can ask a human, do you think these two records are the same person? Yes or no. That's how we create training data. And we can also numerically summarize how similar or dissimilar those records are and feed that into a computer model. And we can do all kinds of string metrics and comparisons and look at tokens, and we can look at how many days apart the dates of death are and how different geographically the locations are. And those are the two key pieces of information that we feed into a classification model. We give them the human-labeled training data, and we give them the features, the numerical summaries of the similarities and the differences between those records. And fortunately for us, sklearn has baked in basically any classification model you might want to consider, and a variety of diagnostic tools. So just as an example, we might look at random forests, decision trees, and logistic regression. And again, feed them that human-labeled training data and those feature vectors, that numerical comparison of the pairs of records. And then we're going to get back a score. We call it a probability. We're playing fast and loose with our terminology. But essentially, we're going to get back a number that we can set a threshold on and say, above that, I'm going to call this the same person. Below that, I'm going to say these are not the same person. And so that gets us to classification. Now, eventually, we're going to have to work our way through the rest of this diagram. We're going to have to decide if record A and record B are the same person, and record B and record C are the same person. Are record A and C? And we're going to have to form some clusters. We're going to have to break up some clusters. We're going to have to do some more post-processing and human review. But eventually, we're going to get to the end of this record linkage problem. And what we're going to have at the end of that problem is a database that tells us the number of uniquely identifiable victims who've been documented by one or more of the sources that we have access to. Now, that's not the same as the question that I started this talk with, because I have slightly misled you. We're only about halfway through this problem. Because what we have done now is we've identified that subset of identifiable victims. And our job as data scientists is to recognize that there's some amount of the population that we don't know about yet. And we need to use the rest of the tools in our toolbox. In our particular case, that means MSE, but we have other options, to estimate what we don't know. And so that's really the next step. If we want to be able to answer this substantive question, we have to do more than just look at what we've been able to document and record. Unfortunately, that's a whole nother talk that I don't have time to give you this morning. So I will go ahead and stop there and say thank you, and I'm happy to take questions.
Thank you so much, Megan. Terrific. Okay, I'm sure there are lots of questions. Can we have a mic here? And maybe in the meantime, another mic is already ready? No? No, you're as fast as it.
Hi, Megan. Great talk. I have a big picture question, not just to you, but for the tech leaders here. I'm a postdoctoral researcher working on climate and energy data.
Great.
So, as you know, we are under immense pressure under new administration. EPA is at risk. And we have been recently notified that whatever research we do is going to go under quote-unquote political review. So I want to know if tech leaders will be willing to step up to fill this gap, because this is going to be the next big humanitarian crisis, and we have been muzzled. And so it's not just from the business point of view, but from the independent research point of view, if they can step up and fill this gap.
I could not agree more. It's easy for me to say, since I work in the nonprofit space, to say We occupy that space now, we're gonna keep occupying it. I hope that other tech leaders will step into it as well. One of the things that we all reflected on our team after the election was that for the last 25 years, we have held state leaders accountable for violations of human rights. And we will continue to do that at home and abroad.
Thanks so much for your talk. My question gets at something that you were talking about at the very end. So we know, of course, that many of the people that die in wars like Syria are not killed directly, right? They're victims of disease and indirect consequences of conflict. So are you guys trying also, as you're estimating the number of people who've died, to get at those kinds of effects, or are you just trying to get at the number of people you think have been killed in actual violent events?
That's a great question. Our particular project and our particular analysis focuses on what we refer to as conflict deaths. So those are directly related to the violence. And the MSc methods that estimate what we're missing, like any other inferential method, are based on what we are able to observe. And the lists are conflict deaths. But if we did want to get at indirect deaths, then we might use more conventional public health approaches like a retrospective mortality survey or a household survey or other demographic techniques to look at what we would expect the population distribution to be to try and get at some of those questions. We're not looking at that right now in Syria. We have historically taken that approach in some of the other conflicts we've worked in.
We have a Twitter question.
From Twitter, we have, how do we incentivize data science for social good when it's often not coming with a direct monetary benefit?
That is such a great question that I have been pushing on other people in my field really hard, and I wish I had a better answer because I meet young folks all the time who want to go into this field, and I want to encourage them, but it is a hard reality that there are not a lot of jobs in this field. And I don't have a very good answer for how we can grow the support for the infrastructure that is going to be required to create more organizations like mine, more centers, more places that can then hire folks to do this kind of work. Unfortunately, I don't have a good solution to that.
It would be great actually if the big companies would dedicate a certain percentage of their research capability to those questions.
I would love that.
Wouldn't it be great? I'm just putting a bug in people's ears here. Think about that. We need it more than ever. We have time for one more question from the audience.
Hi, so kind of on that note, for those of us who are still students who might be interested in doing kind of data science for public good, what recommendations do you have for either skills or experiences or things for us to go after?
Sure. In terms of skills and experiences, I mean, I think mostly it's a lot like the last answer to that question. It's just being really creative in your problem solving and being really open-minded, because our data always break all of our toys. And so you have to kind of be willing and comfortable to think about weird corner cases and build your methodology out to suit your needs. In terms of resources, we could talk a little bit more offline, but the main two that I usually recommend to students, unfortunately they're not money-making, but they're a good way to kind of get a sense of the landscape, is within the American Statistical Association, there's a group called Statisticians Without Borders. And they're all volunteer, and anybody can sign up for their newsletter, and so you can get a sense of the work that's being done. And then also DataKind, which again is a volunteer organization. It has chapters in a variety of locations, including here in the Bay Area. And again, it can be a way to get a sense of the problems that are out there and the questions that are being asked.
Fantastic. Thank you so much, Megan, for your work, for your talk, for everything.
Thank you.
Yeah.
So that's all the video screen today. And the next part is really exciting part. So we're gonna have 3 superwomen in the data science field gonna share their own career advice with us. So first speaker is Julie from Twitter. Julie is a superwoman too, because she is not only doing all the cool stuff at Twitter, but also leading a lot of the community, externally and internally. And you should be really excited about her presentation today, because she's gonna show how to become a data scientist and all the interview process and all the secrets she has. So let's welcome Julie.
Hi, everybody. Thank you so much to Chloe and to She Talks Data and Women in Machine Learning and Airbnb for hosting this. So hi, I'm Julie. I'm a data scientist at Twitter. And I want to talk a little bit about what it means to be a data scientist, how one becomes a data scientist, and then finally what the interview process is like, because I think it's a little bit different than a lot of other sort of interview processes that you see for, say, developers. So first of all, why am I up here talking to you? So I got my PhD in astronomy, and towards the end of my thesis, I was just super burnt out, like you do. And I was like, I don't want any job with science in the title. And a lot of my cohort was trying to find data science jobs in industry. So I came to, did I do something weird? I came to San Francisco to go to Hackbright Academy to become a software developer. And in my interview process, one of the companies that I was interviewing with was like, can you talk to one of our data scientists? Your background's pretty technical. So I did. We worked through an ad tech attribution problem, and it was like a ton of fun. And so I'm like, maybe this is what I want to do. So I ended up joining that company, and it was great. Since being in the Bay Area, I've worked with PyLadies SF, and I'm one of the co-organizers. I've been trying to bring more data science events. So if you're interested in attending or hosting an event, please come find me. The other thing that I've been really involved in is the SciPy conference. And so we'll be having our next conference in July in Austin, and we're going to put out our call for proposals soon. So again, if you're interested, please come find me. We're looking for submissions and volunteers. And eventually I made my way to Twitter, and so here I am today. So what does it mean to be a data scientist? When you do a Google image search, you get pictures of people standing in front of blackboards with numbers and a lot of Venn diagrams and cute infographics. But what I actually think is at the heart of data science is your job is to make other people better at their job. So how do you do that? So I very strongly believe that data scientists wear lots of hats, and so you can kind of map it to other parts of a company. So you have to do sales. You have to get people on your side and get them to hand you their precious data, and you have to convince them that you're going to do something with it that will help them make a decision or help them power something that they're building. From there, sometimes you have to do full stack engineering all the way down to data engineering, which is the case at Twitter, to the analysis, so the science at data part of data science. And then finally, you kind of have to do, say, front-end work and take the research that you've done and give the results to people in ways that they can understand it. So that's through data visualization, that's through dashboarding, in a lot of different ways. The most important aspect, and this might be controversial, but I believe the most important skill you can have as a data scientist is a great ability to communicate, because you can do the most amazing research, you can implement the most cutting edge algorithm, and it can be perfectly optimized. But if people can't consume your results, then they can't use your work. And then finally, you kind of have to be your own product manager. So you need to sort of take all of creative ideas that you come up with to do with data and take an idea from inception to completion. So sounds like a pretty cool job, right? So how does one become a data scientist if they have a non-traditional background? So good news. I really feel that all data scientists have a non-traditional background. If you look at the stats, about 50% of data scientists have PhDs. If you don't have a PhD, that doesn't mean that you can't be a data scientist. And there are three kind of main ways that I think people can get into data science. So the first way is the way I came was through academia, and there are two sort of paths, I think. One is sort of traditional academia, you go to grad school, you get your master's or PhD in a hard science or econ, math and stats are really great backgrounds as well. And the skills that you learn in grad school from presenting at conferences, writing papers, writing for grant proposals, all of that stuff you can use directly in your data science toolkit. The other way that's new and kind of interesting is data science master's programs, and they're all across the country. There's one nearby at Berkeley, there's a Masters of Analytics at UCSF, I know that there's a program at Harvard and UC San Diego, and they're more sort of comprehensive. They're deep dives into specific skills that data scientists use. They go over machine learning, they go over data viz. You do a lot of really interesting projects, and a lot of these programs have connections with the industry, which is great, because one of the things that I felt like I lacked coming from astronomy was I didn't necessarily know how to work with, say, ad tech data. And this Masters of Data Science programs will let you kind of get experience in that way. Yeah. Another, wow, that's really exciting. Another way that people get into data science is through boot camps. And there's several around the Bay Area. They're 12 to 16 week immersive programs. They can be a bit expensive, but they often have connections with industry as well. And so at the end of the program, there'll be a career fair where you can present projects that you worked on. And a lot of these companies that are connected with the boot camps are incentivized to hire grads. There are a couple programs that are specifically oriented for PhDs, and I like to sort of think of them as data science finishing schools for people who are trying to get out of academia. And the last way that I think is probably the most accessible for people is lateral moves. So, you know, you're a programmer or you're a data analyst and you want to become a data scientist, and that's awesome. So, like within your company, see if you can take on more data science-oriented tasks. See if there's like a dashboard that you can help make or some insights that you can offer. And if that's not necessarily possible, like work on personal projects like in Kaggle or do sentiment analysis of Twitter data and build up your portfolio. So when your company's like, I want to hire a data scientist, take advantage of internal transfers because it's way easier to move somebody over than it is to ramp up a new employee. And use your experience as a developer or as an analyst or as a PM to like leverage how your data science process works. So you've decided to become a data scientist, you've come in through one of these many different ways. How do you get through the interview? So data science interviews are a little bit more involved, I think, than developer interviews. And these are all sort of different components. I would say that you don't get necessarily all of them in one go, but sometimes you do. And so I want to talk to each of these a little bit. So the first thing that always happens is there's a recruiter screen. And you and the recruiter talk about a skill fit, like what language do you code in? I code in Python, great. A little bit about culture fit, and very occasionally I've gotten technical questions in these interviews, but they're pretty simple and they're kind of, I think, just like baseline tests to see if you're a good fit for the role that they're looking for. Your recruiter will be your best friend through the interview process, so please be nice to them. Yeah. So the next thing that sometimes happens is a programming challenge, and this is something that I've seen more often in dev interviews, but I have seen them in data science interviews. They're a technical coding challenge. There's usually a question that you have to answer, and this test asks like to see, does your code run? What's a runtime if we use it on a big data set? And it's hosted on a site like Codility or HackerRank. More common is the technical screen, and so that's where after you talk to the recruiter, you get to talk to somebody who's a data scientist or a data engineer, somebody on the team that you'll be working with. And oftentimes you'll do a screen share and you'll do like pair programming and they'll ask you a question. This is where a lot of times they'll ask you stats and probability questions. So dice questions come up an awful lot and other brain teasers. Sometimes they'll kind of ask a product intuition or a data sense question, which makes a lot of sense if you're doing analytics or machine learning work for features that your company would be releasing. And then finally, programming questions come up a lot. And I think it's sort of inescapable. Like it's one of the most foundational tools in your data science toolkit is to be able to program well. And this includes a scripting language like Python and R, but also SQL. Another component of the data science interview are case studies. And this is kind of the most exciting part, in my opinion, because it's the only part of the interview that you get to pretend to be a data scientist. So you get to see what it's like. And so often you're given a data set and you're either asked to answer particular questions or you're asked to like explore something or plot stuff. And then there's usually a presentation component. It could be making some slides, it could be writing a document, and it could be like you've done an analysis and then you come to the company and actually present it. And so this is kind of your time to shine and your time to really experience like life as a data scientist. So once you get through all that, the next is the on-site interview. And there's like a lot to cover because again, data science is a pretty expansive field. My team has been doing a lot of interviews, and so what we've generally looked for are coding and SQL skills. We'll ask questions about algorithms, like how to answer a question, what's the most efficient way, and machine learning is kind of where that comes in. And then stats and probability. Product intuition and experimentation are really important, especially at Twitter, because we try to innovate through experimentation. And so we do a lot of A/B tests, and we have a framework for that. And so we want our data scientists to be able to come up with like logical metrics and ways that we can move forward. And finally, like as with any interview, there's always questions of fit. And I think one thing to keep in mind is like it's scary to be in an interview. They're like 5 hours long. You've like done like 17 other things for this company, but you're also interviewing them. So you want to see if it's a good fit for you and to make sure that it fits into like what you want to do and where you think you want your career to go. So it's a lot, obviously, but it's not impossible. Like I went through it and I made it, and everybody else who's about to speak has also gone through it as well. And so there are a lot of amazing resources out there. One of my favorites is Claire Cortell's Open Source Data Science Masters. It has a lot of like lessons and ways to learn. And I'll give these slides to Chloe and she can post them. So thanks.
Thank you, Julie. So hopefully you can have some idea about the interview process and learning more about data scientists now. So next speaker, we're really excited to have Ranjani because she is all the way flying to San Francisco from Portland for us. She's currently the data scientist in Intel, and before that, she was working for Apple. So really solid background. And let's welcome Ranjani.
Thank you. Good evening. My name is Ranjani Ramakrishnan. I'm a data scientist at Intel Corporation. And for those of you who are old enough to remember, Intel is one of the few companies which actually put the silicon in Silicon Valley. So I'm really honored to be here today to give this talk. And I just wanted to share my experiences of how to be a data scientist in a more mature company, not necessarily a data-centric company, although we are pivoting that way, but a more traditional, more mature, established company. So my background is I was a data scientist at Apple prior to this, and before that at SAP. And I was working on my dissertation when Apple came calling, and I chose to have a life, meet friends, meet my kids, instead of submitting my dissertation. And that's how I ended up being a data scientist. So let me tell you a little bit about Intel and the group that I work in. Intel, as all of you know, makes computer chips. And right now, we are present in a number of different products, ranging from your supercomputers to mobile devices to IoT products. And what I want to emphasize is the division that I am in is primarily focused on manufacturing. It's called the Manufacturing Validation Engineering Division, and it's responsible for converting every piece of silicon that Intel actually manufactures into a workable product. So, data science is not new to Intel. It's something that they've been doing. It's ingrained in their blood, and they're very successful at it simply because they've been putting out successful products that people run all their algorithms on over the years. Why are they looking for data scientists? And by the way, if you people are interested, I have some handouts over there. We're really interested in hiring data scientists. So either come talk to me or pick up one of those little QR codes and go and apply. But what I want to point out is it's not new to Intel. And our target audience is very different than the traditional consumer. We are interested in making better products. We are interested in enabling the technologies for the future. And to do that, we have to make the best product available across multiple verticals. And like I said, MVE, which I'm a part of, is sitting right in the middle of that process, right between design and high-end production, and we make every product into a usable product. Okay, I already said data science is not new to Intel. So why this push to get data scientists? We call them by other names, by the way. But this new push is because I believe of three main reasons. The first thing, we are making many, many more products than we did previously. I think just the fact that we are in the entire spectrum, all the way from servers, as I pointed out, to the IoT devices, is proof of that. The second thing is we don't have the luxury of creating a product over a specified amount of time. Given that we are in different form factors, we have to turn around really quickly. So we really have to accelerate our product development cycle. And then the last part is the increasing complexity of our chips. You probably have heard about the Intel roadmap. We're already at 14 nanometers. We're going towards 10, probably smaller. We have to keep beating Moore's law, and the complexity just keeps increasing. So we need to come up with newer ways to address all these problems. That's the only thing that's different. As somebody once said to me, yes, they're all algorithms. Yes, it's just that we're seeing it in such a totally new scale that we haven't seen as we did before. So my challenge as a data scientist in MVE is three parts. One, help develop or help accelerate the product development cycle. Two, help the organization learn or share learnings really quickly and across the different verticals. And three, we have to develop new insights. And to me personally, that's the exciting part, because I try to come up with new ways of looking at data, develop my own algorithms. And it's also it's kind of interesting because you also have some of the newer products to try them out on, which may not be available outside. So given that context, I'm not going to talk about the technical challenges. I'm just going to talk about some of the lessons that I've learned in working in such a company. And the very first one is never underestimate the power of simple analyses. Simple analyses does not mean simplistic analyses. And I'm going to take the example. One of the things, or one of the products that I was tasked to work on was an analytics dashboard that I had to put together. I had some other really interesting projects that I was also working on. I thought, okay, 20% of my time I'll spend on this. And I pulled in all the metrics, ran some simple trend analyses, brought in data from, multiple sources, multiple divisions, some of it from manufacturing, some of it from quality, some from even external customer facing metrics. And you would not believe the impact that that had. Today, that dashboard is actually driving deliverables for two big organizations at Intel, close to, at least one of them is 5,000 plus, which is the organization that I work in, and another one which is at least 1,000 people. And it's driving directly the work of 100 plus teams of people. So that was a big lesson that I took away. Never, ever underestimate the power of simple analyses. The second one is you really need to understand what has been done before, and more importantly, why it was done the way it was. And I believe this is important for three reasons. First, it's going to help you focus your problem on the actual problem. You'll be able to understand what the problem is. You will understand what the gap is between what currently exists and what needs to be done. And the third, and that is very important because you have to end up convincing people to buy your solution. And I use the word buy very loosely over here. And in most cases, the people that have to buy into your solution are usually the people that put the original solutions in place. So make sure you understand what the gap is, understand what is lacking, why it is the way it is, and then come up with a proper fit. The third lesson that I took away is kind of related to the second one, but it essentially just is work with partners. You cannot do things in isolation. And it might seem very obvious, but when you work with partners, you don't just understand the technical challenges you have to solve. You also start getting a sense about the non-technical issues which you may have to deal with. And a very simple tip, and I learned this the hard way. I had to make a presentation to a large group. I spoke with very limited set of people. I totally underestimated that there might be other key players in the group who would have a very different reaction. Luckily for me, I was able to get out of that situation because basically all of them were nice people who were not wedded to the solution that they had in place. And once I circled back with one-on-ones and help answer some of the questions they had in a one-on-one setting, it really made sense for them to accept the solution. But you may not be so lucky. So do your homework in advance. Just go ahead, make sure you understand who the key decision makers are in a group. Talk to them, or talk to most of them. At least at Intel, we have this policy that you can always go and talk to people. People will always give you their time, as long as you don't waste it. So do your homework, make sure you talk to people before you go in and make that big presentation. It will help in getting your solution across and accepted. The fourth one, which may seem a little counterintuitive to people, but I have found it to be successful both at Apple as well as Intel, is bootstrap your way to success. Don't expect to be handed a full team on day one. It is not gonna happen in most cases. Get creative in how you find resources. Keep very focused, be very, very focused in what you're promising to deliver. Make sure that you deliver fast and deliver quickly, so that'll allow you to course correct. And if possible, stay under the radar as much as possible until you're ready to unveil the project. Just talking to my mentors, both at Intel and Apple, I found that according to them, most projects fail and they're not successful. It's not because they don't have a good technologically relevant solution. It's mostly because their focus has been diffused a lot and they have overpromised things to people and they are not able to satisfy expectations. So don't fall into that trap. And then the final one is share your learnings. And I think this is really important because when you share your learnings, people will realize that you are generous with your learnings and they will be able to tell you things as well. And that way, you don't just build your network, you're also pruning that search space. You're not going to go down a path which has been explored previously, which was considered not relevant or important, and you're really not wasting your time. It really helps you focus. That pretty much was all I had, and I think I just want to finish on a personal note. Parents in the audience might relate to this. But I was reading a bedtime story to my 5-year-old daughter yesterday, and we read the story about Gerald the giraffe, who is considered the most clumsy dancer in the entire jungle, but at the end of dance day was declared the best dancer. And when all the other animals asked him what the secret of his success was, he said, when you find the music you love, then you become the best dancer that you can. So I'll leave you with a message. Just go find the music you love, and you'll be the best dancer that you can. Thank you.
Thank you, Ranjani. The next speaker is gonna be our last speaker tonight, and before she come up and share her experience, I wanna make a confession. So I actually socially stalking her for a while. Why? Because she is really, really cool. She got her PhD from Stanford and studied applied physics. Sounds really, really difficult to me. And also, she has been leading a data team at Airbnb. And it's always so exciting to see women become so successful and excel in the data science industry. So Lisa today is gonna share her adventure as a data scientist and some of the transition from academia. So let's welcome Lisa.
Thank you for the introduction, Chloe. Okay, so as Chloe mentioned, I am a data scientist at Airbnb. I've been here for about 3 years. I am now managing a group of people working on search. So in the next 10 minutes, I'll share a little bit about how I got to be where I am and some surprises that I encountered along the way. So how did I become a data scientist? As Julie mentioned a little while ago, most people take untraditional paths towards this role, and mine was no exception. So I started, I went to college at Rice University in Houston. I studied electrical engineering and physics. My dad was a physicist. He actually worked at Intel in Portland. That was what I knew that I was going to do. I really loved studying physics. I did a few internships at Intel during the summer in different groups. And the summer before I graduated, I actually did a research fellowship at a university working in an experimental physics lab on magnetic sensors. And I loved working in that lab. I loved everybody that I met there. I loved the professor. And I decided that I was going to do that for the rest of my life. So I did my PhD in physics at Stanford. This is some of the stuff that I did while I was there. So I used a special microscope that my lab specialized in. It's called a scanning squid microscope. That stands for a superconducting quantum interference device. And we scanned it over different surfaces and measured the local magnetic field. So this is, these are some pictures I took. This is a picture of a bacteria that has magnets growing inside it. And on the bottom is what the magnetic field of that looks like when you scan over it. So that was cool. So I was like in a really good state for about 3 years, I would say. I worked most nights and most weekends. Most of my friends were physicists. I even met my husband in the lab. So it was like basically like all of my entire life was spent working on this microscope. And I really enjoyed it for a while. And then after about 3 years, I started to think about my future a little bit more. And I took a look at and by this time, some of the postdocs and older graduate students that I had started with, they had moved on. And I started thinking about like what they were doing with their lives. It seemed like everybody was either taking this setup and their goal was to do the exact same thing somewhere else. So actually the postdoc that I worked most closely with, she did the exact same thing in Israel. And somebody else did the exact same thing in Boston. So it was like, okay, the world can take a few more of these setups, but maybe not that many more. And did I really want to be focusing on this very, very narrow field for the rest of my life that didn't have very many practical applications. Everybody else who wasn't taking this same setup to another place was doing other things. So some people were becoming software engineers, some people were starting their own companies, but it tended to be a little bit of a struggle. And so I spent the next 3 years of my life in the space I call exploring other options. So fortunately, I was at Stanford, and there were plenty of opportunities to do this. I started living outside of the lab. I explored classes in different areas. I took classes in computer science. I studied statistics a little bit more. There was a phase where I wanted to be a management consultant. I think there's a lot of people who go through that. What else did I do? Oh, I even took a class at Stanford called Designing Your Life. There's a lot of people who struggle with this. So after 3 years of not knowing what I was doing, all of a sudden I hear about this field called data science. There was actually a former lab mate of mine who started doing this, and I had never heard of it. I didn't know what it was, but as part of my research, I was analyzing data, so I thought I was pretty good at that. And I was a scientist, so that kind of made sense. And around the same time, I heard about this program called Insight. This is actually one of these boot camps that Julie talked about earlier. It was very new at the time, so they came to the Stanford Physics Department to tell us about it. Yeah, so this was a 6-week program that basically helped bridge the gap between people in academia like me who were looking for other opportunities and connected us with companies like Airbnb who were looking to hire more data scientists. So I went through that. I actually took a few classes before I went through that. And just to see if this was a good fit for me before I joined. And I thought I would give it a try. And so after 6 weeks of that, I interviewed at Airbnb, and I've been here ever since. So yeah, so that's kind of it. When I was at Airbnb, so I've been here for over 3 years. I've worked on a few different teams. For the last 2 years, I worked on search. So I actually talk a little bit about some of the stuff I do there coming up. But okay, next I want to share with you some of the biggest surprises I encountered in my last 3 years. I mean, I had talked to people who worked at different companies, but these were kind of like things that maybe seem obvious now, but they weren't obvious to me when I started. So the first thing that I was surprised by is, unlike in academia, actually it's encouraged to copy other people. So in academia, we had this thing where like everything had to be original, all your research had to be original. Actually, I found out halfway through my PhD that there was another team at Harvard who was like trying to do the same thing that I was doing, but using a different device. So it was like, oh, I got to get that done before they do, and like better not share my findings with them, or it was very weird. So I grew up, or I went to school with that kind of mentality, and it's actually very different here. If anything, it's quite the opposite. So we do a lot of competitive studies. So we'll like look at competitive websites or like other things or other products, see what other people are doing. Because if somebody else is doing it, there's a reason. Either they thought that it was a good idea or it is a good idea. So it's worthwhile to at least consider it. And then also, it's really encouraged to share ideas amongst each other inside the company. So if you develop a new way of solving a problem or a new algorithm, it's really useful for you to share that with others to see how you can scale that work to allow other teams to do it so that the entire company can be more efficient. So that was something that was very welcome, and I was very happy to find out about that. The second a big learning is that sometimes the hard part is not really like solving a problem, but it's defining what the problem is. So I feel like when I was at school, and even during my PhD, usually the problem was pretty well defined. It was like, okay, like solve this problem set, or you have this particular microscope, figure out a way to get measurements on this one device and prove this thing. So it was just a matter of trying over and over to get that done. But here, I found that sometimes the hardest part is actually figuring out what you want to solve. So as an example of that, I'll talk a little bit about what I work on, search. So Airbnb is a marketplace, so we like to think of search as being the matchmaker between the guest and the home or the host. So let's say that I am going to be going to a conference in Houston next month, so I would like to stay at an Airbnb while I'm there. I go onto our website to look for a place. I type in a search query, where, when, and I'm traveling by myself. So this is what I tell Airbnb. But what's really going on is I'm actually much more complicated. So I'm going to a conference. I would like to be close to the convention center. I'm traveling by myself, so I would like to stay in a safe neighborhood. Most likely in the evenings, I'll be answering emails, so it's important to me that the place has good Wi-Fi. I like to work from cafes during the day, so I want to be walking distance to cafes and restaurants. I have a budget, like about $150 a night, but I'm willing to go a little bit higher if it's something really special. And I don't really mind if I have the place to myself or if I'm staying with a host, but if I am staying with a host, I want it to be somebody who I really get along with, who gives me some freedom, but also shows me around. And I also want something that's like modern and bright, has a nice feel to it. Okay, so these are all these other things that are going on in my head, and there's no single one place that is probably like a 10 on every single line here. But as I'm going through and refining my search query and I'm looking at different homes, I'm making a set of complex trade-offs and balancing which one of these I'm valuing more and which of these I'm willing to trade off to gain in another dimension. So what is some way, what is a way that we could actually find out about this and help the guest, because there are thousands of places that I could be looking at. So some preferences we collect explicitly. So this is our filters panel. You can enter in your constraints for price. You can tell us that you want only to look at places with Wi-Fi and 24-hour check-in, et cetera. But this can be cumbersome, and also not everything is here. And then some preferences can be inferred. So for example, if you look at 5 places and they're all less than $50, maybe that tells us something about what your budget is. So we can tell about how sensitive your price is. We can tell how sensitive you are with a location. So maybe everything that I look at is within a 2-block radius of the convention center. And then there are also some other latent features, like if I only look at places that have photos that are bright and modern, that tells me something about my preferences as well. And then also where you're coming from and where you're traveling to could give us more information. So say there's a big conference somewhere, and we know that you're going there on these specific dates. We could learn some things from there. So then it becomes the goal of search. It becomes much more exciting than to just figure out what's the best way to order a list of homes on the search page. It becomes a question of like, how can we balance these implicit and explicit preferences? How can we figure out a way for guests to engage with our products so that they can tell us these preferences in a natural way, or that we can infer them? And how can we use that data that we collect to then make this matching process easier? Does that make sense? So I think I'll kind of like leave it there for you guys to like ponder about. This is just like a taste of the kind of problems that my team and other teams work on in this company. If you have any more questions about what it's like to work at Airbnb, what search here is like, or just any questions about me, feel free to contact me. Thank you.
Thank you, Lisa. So now we're gonna invite all the speakers come up again, and you guys can ask questions now. Sorry? Yeah, because we're running late a little bit, so probably 2 or 3 questions. Anyone question about anything? You're in the data science industry, you have to be curious, okay? Okay, there's a question. You're a good data scientist, right?
Yeah. Oh my God, this is loud. This question is specifically for Lisa. I was kind of just wondering because, like, I used to be a host on Airbnb, and I've stayed with Airbnb as well. So I was just kind of wondering how you balance, especially in search, because I know that like hosts get higher up in the search algorithm, whether they're super hosts or not. So kind of how do you balance being appealing to the user and to the host side in kind of like the problems that you solve?
Okay, this is a good question. So you're asking about how, like, about whether or not we optimize for the guests or for the host in search. So the issue with the latter, with optimizing for hosts, is that if you bump up one host in search, that means you necessarily have to bump down another host, right? So it's difficult to be in a state that is the best for everyone. Like, not everyone can be ranked first. So what we like to think of is it's more of a matching problem. So one host might be a better match for one guest and not as good of a match for another. So we try to treat it more for like a personalization/matching problem. So in that case, some hosts might be ranked higher for other people, for one guest than for another. And so we're continually working on ways to improve that process, but that's how we think about it.
Thank you. Any other question? Okay, great. What's your question? Yeah, that's you.
So data science is both a very young field, and many data scientists are also very young. What do you see as the long-term career path for people, how you're being hired as data scientists and then going up either within the same company or an industry?
Yeah. Julie or Ranjani, you want to take a question?
So I think in my experience, data scientists aren't like developer young because a lot of us have PhDs. So I'm 30, and so I got my first job when I was 28. In terms of like long-term career pathing, I think that like there's always sort of been sneaky data scientists like way back in the day, and so these are the people who are now your chief data scientists because they were research like developers or something, and they're like leading their own companies. My hope in the future is to become a data science manager. To help provide opportunities for minoritized folks to get into data science.
Thank you. Well, think about it as you would any other career path, right? Data science has been called by other names before. People have been called statisticians. Nowadays, you call them data scientists. It really depends on what you want to do. Maybe you want to remain a data scientist and you want to get your hands dirty with the data. Or maybe you want to do something different and you want to manage a team of data scientists. Or you want to drive a program, for data scientists or for enabling data science across your organization or company. I really think it depends on how you want to tailor it. And a lot of it will depend on your personal preference. Yeah, I think I'll just stop there.
Yeah. One last chance. Any question? Okay, there's so many. Okay, you.
I have a quick question for all the speakers. Like, what do you see as the advantage or disadvantage for being a female data scientist?
Anyone want to jump into the question?
All right.
It's a hard question.
I think it's true as for any other female engineer. I've been on teams where I was one of 2 women in a group of 100+ women. The current position I'm in is a little different. We have more technical women. And you just find ways to, well, depending on the situation, ignore it. I'm being very practical over here. Or sometimes you have to come up with coping strategies. It might be something as simple as getting interrupted in meetings. What do you do then? I've always found that, you know, I try to think of situations in advance. I share with my friends. They give me tips. When I go in for meetings, if I think it's going to be a situation where I am going to get interrupted, I'll have a buddy who'll help direct the conversation back. And I really want to share this story that I had. It happened to my sister, who happens to be a director right now for a product. And she was making a pitch to a CEO and a CTO, I believe, of a company, along with her colleague. And it was a table filled with men. And she pretty much finished her pitch, complete silence for 2 minutes, and then this other guy goes ahead and he repeats the exact same thing that she said, and she finds all the men around the table nodding their heads. Well, how would you cope? So she did it very gracefully. She just turned around when he finished, smiled, and said, "Thank you, I'm so glad you agree with me." End of story.
Thank you. Obviously, there are so many other questions, so stay with us. We still have like 15 minutes. You can come up to ask questions or social. And thank you so much again for coming. And our event gonna conclude here. But please help us to clean up your dishes before you leave. And we hope to see you again. Thank you so much.
Drop it for me. I'll rent a beach house in Miami. Wake up with no jammies. Lobster tail for dinner. Julio served that scampi. You got it if you want it. Got it if you want it. Said you got it if you want it. Take my wallet if you want it now. Jump in the Cadillac. Girl, let's put some miles on it. Anything you want, just to put a smile on it. You deserve it, baby. You